There's something almost magical about interactive snow in games. It's just so satisfying to see the world react to your every movement. I was curious how effects like this are actually implemented, so I decided it would be fun to try to recreate it myself. I thought this would be a quick project, but I was wrong. I ran into some tricky challenges along the way, but it was so worth it. So let me take you on my journey of creating an interactive snow system in Godot and everything I learned along the way. I started out by making a new project in Godot. My initial goal for the project was to just get a snowball moving around a ground plane and affecting the height of the snow as it moved. I've been doing some research and thinking about how I might implement this effect. I think the basic idea is that as the player moves around the ground, which is the snow layer, we will use a vertex shader to manipulate the height of that plane mesh to make it look like snow is being removed or added. The simple way to do this would just be to track the player's movement and then draw a sprite or a simple shape to a mask texture and then read from that mask texture in the snow vertex shader to decide how to offset the vertices. The problem with this approach, though, is that the snow won't be as accurately deformed by the player character because it will depend on whatever sprite you're using to draw to that mask texture, which could just be like a circle or something like that. But what I'd like to do is instead try to implement something more general so that it will look more accurate and work with any character, from snowballs to robots to animals walking around. And to do that, I think we can use a different method involving an orthographic camera. The basic idea behind this other approach is that instead of just painting a specific shape to the snow mask to tell the snow how to offset its vertices, I would instead use a camera to get its view of the world and then use that information to offset the snow more accurately. And I could also get the depth information from the camera to actually see how much each object in the snow is actually impacting the snow. So that means if a character was all the way in the snow would be impacted more, but if a character was just brushing their foot on the top of the snow, you could show that as well. I had read about this approach online, but I couldn't find any good examples of it being implemented publicly in Godot. All the other things I found were the simpler approach, so I wasn't sure how to do it exactly, but I thought it sounded really cool, so I wanted to try. I started out by creating a snow ground plane and subdividing it a bunch to make it so the vertex shader would have a lot of geometry to work with for the snow deformation. I added a shader material to the plane, and then I created a snowball that could be controlled by the player. I got the snowball rolling around. I make the camera follow the snowball too. I realized I had never actually coded a third-person camera before, so I spent a bit of time figuring out how to do that and setting it up. I had some difficulties getting this to feel correct, but I eventually got it working using a spring arm to prevent the camera from clipping into nearby objects and move with the player better. I wasn't totally satisfied, but it was working well enough. Then I started working on the actual interactive snow part. I set up a viewport to put the camera in, which I needed because then I could get the viewport texture to reference the camera's view in the snow shader. And then I added an orthogonal camera underneath the snow mesh and pointed upwards towards the ground. So you want it to be orthogonal so that perspective doesn't matter. I think we also want it to only see above how high we want the snow to be. I set up a debug mesh in the world to see the camera's view so I could get an idea of what was actually going on. A lot of problems going on here. I don't want to render the sky in the viewport. I don't want it to clear. I realized I could change the environment in the viewport to just have a clear color and not render the sky, so that was good. I realized I could also set the camera to keep, and that kind of worked, but not how I was hoping. And then it hit me that I was actually completely thinking about this the wrong way. Maybe I'm thinking of this the wrong way. Maybe this just needs to have a shader that creates a depth texture and somehow saves that between frames. Instead of rendering the camera's actual view of the actual environment, what I really wanted to do is render the camera's view of depth and how far away different objects were from the camera and use that as the mask texture instead. I'm still pretty new to this area, but basically cameras keep track of depth information to help the game engine determine what order to render objects in and which ones should be on top of each other. So if you want to, you can access this depth information through a depth texture and then use that for post-processing effects in a shader. So I copied some code from the Godot docs to get a full screen shader working and display depth information. And it was working, but I didn't love how the full screen quad would affect the view of everything, including in the editor. Maybe that's actually working? I still don't necessarily want to see that in the editor. So I wanted a different solution. I realized that since I was using an orthographic camera, I could just create a quad that was the same exact size as the camera's view and put it directly above it, and it would act as kind of a filter of the camera's view. So like this is kind of working. Like it is visualizing the depth from the camera. Going more towards red is closer to the camera. Max red is closest to the camera. Depth values range from 1 to 0, where 1 is the closest value to the camera. So if you set the red value based on this, objects closer to the camera were brighter red and further out closer to black. It seemed like this was mostly working, but I did notice that it sometimes wasn't behaving as I was expecting. When the snowball jumped, it should have still been visible to the camera, but it was disappearing from the viewport texture early. I also noticed a weird bug where changing the camera's far view to be further, everything was turning red, which should have meant that everything was closer to the camera, but it wasn't. So I wasn't sure what was going on, but I just had to come back the next day. I think it's time for a break. Since I had previously just copied the code for referencing the depth texture from the Godot docs directly, I figured there had to be a problem there, but I wasn't sure what it was, so I spent some time just trying to figure that out. So we're converting the depth to linear depth. Don't know exactly what that's doing, but let's just try looking at depth instead. After some debugging, I realized that if I actually just referenced the depth value directly instead of leaving the conversion to linear depth that I pulled from the Godot docs, it seemed like it was just working. I mean, setting it to the depth value is actually kind of working, maybe. So if I move this up, it goes away. And yeah, the lowest it goes is pure red. So why can't I just use the depth value, actually? What does this mean? So something about that conversion to linear, which was supposed to make things more accurate, was actually breaking things. So I did some research to figure out how depth values typically work. I learned that camera depth values are typically stored non-linearly so that there is more detailed information closer to the camera rather than further away, because it's more important to be accurate closer to the view. But when implementing graphical effects in a shader, you'd want to convert these non-linear depth values to linear to make it easier to tell exactly how far away from the camera different objects are. So that made sense, but for some reason it just wasn't working in my case. I eventually realized that my issue was that I was using an orthogonal camera instead of a perspective-based camera, and with orthogonal cameras, the depth values are actually stored linearly by default because they don't need to deal with perspective distortion. So that meant that the shader code I had to convert the depth values to linear depth values was completely unnecessary and actually messing things up. So now by just switching to using the depth value directly, I finally had a mask texture that would track things as they moved at their correct depths, but there was no persistence going on between frames. But I decided to just start out by trying to get this node to modify itself based on that depth information just for the current frame. So I wrote some shader code to do this, read from the snow mask viewport texture. I got something working here. Like something's happening here. Yeah, it looks like this is like inverted or something, but maybe almost working. In the shader, once I flipped the coordinate in the Y direction, it was working. It didn't look great, but it was working. Don't know what's happening there, but this might be working. It looks pretty bad, but the snow is moving as the snowball moved. And now we just need to get it so that this texture actually saves between frames. I had some ideas for how to do this, but it ended up being a lot more complicated to figure out than I was expecting. The basic idea was that I only want to update the mask texture at any particular location if there was more depth than the previous frame. So if there was more red in that particular location than there was before. Maybe what I need to do is kind of store the texture somewhere and then update it rather than trying to do it all one shader, but I think that's not possible maybe. Like, I think I might need a second viewport and then I can somehow combine these images. So I ended the day with 3 different viewports set up to try to get this idea working, but it just wasn't working and I was confused. I think it's time for a break. I don't think I can figure this out tonight. I'm not really sure how to achieve this. It seems like it shouldn't be that hard conceptually, but I'm just not familiar with how all this stuff should be set up. I realized here that I could actually use GDScript to store the previous frame's texture and then pass it back into the depth shader to combine it. Maybe I just can't do this strictly through shaders. Maybe I need to use GDScript to store the image. But for some reason, I really didn't want to do this at the time. So I kept trying to use the 3 different viewports to pass back and forth these mask textures to combine them. And I got it sort of working. Wait, what? Why is that working? But I didn't fully understand what was going on. What is going on here? And there were a bunch of different issues. You can fill back in the snow by jumping. And also the deform snow just looked really weird and I wasn't sure why. Oh, you know, this is probably something to do with the normals getting messed up of the snow, maybe? Maybe that's why it looks so bad. And that would be another rabbit hole I would go down in the future. I mean, this is kind of cool. I also realized that the texture was somehow mirroring itself in different locations, which was causing the snow to be impacted across the map for where the snowball actually was, which was weird. Why is it mirroring it? This whole thing felt very overcomplicated and finicky. It felt like it was relying too much on weird Godot quirks to get things working, so I wasn't comfortable with it, but I decided to leave it for the night. Well, once again, I'm feeling pretty tired. I guess I've made some decent progress. It kind of looks like you're rolling around in the snow, even if it doesn't look amazing. And if I like lower this into the snow and move it back out, it is indented, which is kind of cool. I finally came back to something I had realized like the first day I was working on this. Maybe I could do something simpler and just get the viewport's texture every frame and pass it into this shader. This approach would allow me to just have a single viewport, which would greatly simplify things and make things way less confusing. I got something working with this, but there were still some issues. Oh, wait, is that working? It's shimmering and it's mirrored. That's something, right? The main issue here was that for some reason, every depth value was coming out at max red, regardless of how far into the snow the object was. For some reason, we're at max height for everything. This is looking promising though. This is feeling like it's so close now. But why always max height? I started trying to debug this by looking at the very first frame in the snow mass texture and looking at the colors there. So the first frame is actually accurate, but then it's turning red. That's weird. But I couldn't figure out what was happening, so I decided to come back the next day. By updating one of these debugged textures after a certain amount of frames and pausing it, I guess we can see how quickly it's changing to full red from being correct. You can see here that looks pretty much full red after 5 frames. What about after 2 frames? Not full red. That seemed to indicate to me that there was some sort of color space conversion issue going on involving passing the texture back and forth between GDScript and the shader. Maybe somehow that's just making it more red over time because colors are being interpreted differently. I eventually realized that the problem was actually quite simple. I guess, could I need this line here? Like that? Wait, that's it? That's the problem? Oh, okay. So now this is working, actually? It was just that I needed to set source color on the previous frame's texture. Without that flag, it was treating this mask texture as if it was stored linearly. But since when you extract textures from viewports, they're stored in sRGB format, which is non-linear. It's actually not linear, and that was causing the color to drift towards red over time. The source color flag tells the shader to actually convert that value back to linear, and with that, it was working. I was pretty excited about this. I finally had a simple solution working after multiple days of trying. Look at that. It's not full depth, and the snowball correctly indents it. Wow, okay. That was actually easier to fix than I was thinking it would be. This feels like kind of an obvious solution now. I think my problem was that I was really just trying to do things through shaders without going into GDScript, and that kind of made sense to me at the time, but this seems a lot simpler. So now that this was finally all working and I was happy, I needed to start addressing other issues. I wasn't sure why the snow looked so jagged as the snowball moved around, and also the shadows looked pretty weird. I wasn't sure if that was because normals for the mesh weren't being recalculated as the mesh vertices changed. So I started trying to figure out how to correct the normals for the snow mesh. Without doing so, the normals for each vertex would be set as if they were still a flat plane, which means that even if the vertices positions were changed in the snow shader, they would still incorrectly treat light as if they were still part of that flat plane. From my research though, no similar Godot projects were actually correctly correcting the normals, so I wasn't sure how important it was or how I should do it, but I wanted to try. So I found a formula online that would allow you to find a normal using the cross product of df(dx) and df(dy) of the current displaced vertex position. For recalculating the normals, it seems like you usually want to use these derivative functions. It seemed like it was kind of working when I visualized it as a color. If this looks sort of correct, I'm trying to visualize the normal map through the albedo. But when using it to set the actual normal value, it wasn't behaving as I expected and was also moving with the camera's view. So you can see what's happening from the top, but when I move the camera down, it's changing the colors, which seems odd. I decided to take a break and come back the next day. I see that this normal value is somehow in camera space or something, and it needs to be converted to something else that it is stationary. So I realized that when setting the normal values in the fragment shader, it was actually expecting the normal to be in view space, which is based on the camera's view, but I was setting this value as if it were in local space, which was causing it to move when the camera did. So I have the normal in local space and I want to convert it to view space. So I convert it to world space and then world space to view space maybe. So I spent some time here figuring out how to correctly convert the normal value from local model space to view space, and then it appeared it was actually working. That might be working. But it didn't actually look amazing like I was hoping. It actually kind of looked worse. Does it even look better? So this is without the normals being set. This is with the normals being set. That might even look worse, honestly, because it makes it look more pronounced, but at least it's more correct, maybe? The important thing here is that the top and the bottom plane of the snow are pointing up. They all have the same normal and the sides don't, and that means I think it's working correctly finally. But I would later come back and revisit this once I had things looking better overall. One thing I just realized is that the best way to see the difference the new normals are making is if I turn off the normals here and I have shadows off on the light, you actually can't see the snow at all. But then if I enable my new normals, you'll see that when I restart this, you can actually see the snow changing. And I decided I wanted to try to figure out why the mesh looks so jagged as the snowball moved through it. I think maybe it's kind of like I need to blur the mask so that it's not as sharp around the edges as the snowball moves around. And I think in other implementations without using the depth texture, this actually happens by default because you can use a sprite or whatever to move around that has blurred edges. So maybe this makes this a little bit more tricky. I tried a few different ways of implementing this blur, including using temporal anti-aliasing. It's almost like the snow is melting over time. I think this doesn't work because it's actually moving the camera that is responsible for the depth texture. I thought maybe a simple solution here would be to use mip maps to just blur the texture by accessing a higher mip map value, because that's kind of what they do. But it turns out the depth texture doesn't actually have mip maps unless you create them yourself. So that required a bit more work. This is gonna be really slow, but let's just try every frame blurring the mask texture just to see if that even works using mip maps. I tried a combination of generating mip maps for the mask texture in the process function and also using an in-shader blur method I found to blur the depth texture directly within the shader, and this looked decent, but I was concerned it was too slow because constantly generating mip maps wouldn't be efficient. I mean, that looks kind of good. Not sure I'm going to smooth out these faces though, because I think that would be nice if the normals were kind of smooth. Then I decided to try to improve the look of the snow a bit by adding a snow texture to the mesh. I also wrote some shader code to make the snow get more blue as objects move through it and as things got more deep in the snow. So I think that I actually should just write this blurring code into the depth shader rather than trying to do the mip map conversion thing. I think that just is too slow and too much unnecessary work. So instead I did some research and got some code working for a different type of blur in the shader to blur the depth texture and therefore blur the mask. And it looks pretty good. Let me just turn off the normals briefly. Yeah, I think this looks a lot better. My problem now is that when I enable normals, it looks worse, and I really would like that code to stay so the normals are correct. So I think the reason why we get this kind of flat shaded look is because when you calculate the normals this way, you're basically just looking at two pixels that are close by in each triangle and then using that to kind of determine where that face is pointing. That means that each face is kind of calculated independently of the ones that are next to it. So you have these hard lines between the faces. I'm not sure if I understand is 100% correct, but it's something like that. So I think if we instead are actually looking at the different vertices that are nearby a specific vertice, we'll then be able to more accurately blend the normals along a slope of the mesh to look more smooth. Since we have the height displacement map, which is the snow mask, we should be able to calculate where the other nearby vertices are going to end up and then calculate the normals based on that, I think. This example here might be kind of what I want, actually. So I spent some time just trying to figure that out. I just stepped away from recording for a bit, and I think I've actually finally figured out the normals. This is what it's looking like now. I think this is the best iteration of the snow with normals enabled. I think it is pretty much accurate now. And this is what it looks like with the visualization of the normals turned on. The ground is mostly green, which is good because it's mostly pointing up. And yeah, this actually looks like it's finally accurate, which I am quite excited about. Now I can finally start to do some more fun stuff and really spruce up this snow demo and make it fun to play around with. And finally now, after many days, I had figured out how to get the normals looking correct for the mesh, and things were looking good. I came back after visiting family for the holidays and decided it was time to start wrapping things up. I realized there's a slight problem here where this block that was intersecting the snow is actually floating if you look underneath it. I'm not sure why that's happening because the snowball seems to be working correctly. I initially assumed that the problem was somewhere in the depth shader that outputs the mask texture, so I spent a while, longer than I would have liked, investigating that and going down the wrong path. I eventually began to suspect that there was another color space conversion issue going on with the mask texture. I'm not sure if it could be some sort of issue with color spaces and precision, something like that. This value should be a linear value. If I, for example, set it to 0.1, it should be 10% of the snow depth, but clearly it's doing more than 10%, so something's going wrong here. After much investigation, I finally figured out the issue. Wait. Should this be here? Source color? Oh no, if that's the problem. Oh. Oh no. I should have caught that earlier, but I think that's probably the problem. So if I set this to 0.5, it should be halfway up. Yep, that's the problem. Can't believe I didn't set that up before correctly, but look at it now. That's good. Now, with all the major issues out of the way, I decided it was time to focus on polishing things up into a final project. One thing I want to try to do is seeding the initial snow with some noise so that it doesn't look so flat, kind of make this more of a real environment. So let's see if I can figure out how to do that. This was actually quite easy to get working, but I did have to spend a bunch of time tweaking values to get things looking like I wanted. Oh, that just worked. That's cool. I mean, that's pretty good actually, just making it really tiny texture so it stretched out and it blurs more smoothly. I also made it so the snow noise would randomize every time you start the game, so it looks a bit different every time. So now we should have kind of randomly placed noise every time. I mean, that looks kind of cool actually with more bumpy snow too. I experimented a lot with different noise values before deciding on something I thought looked good. I think that looks pretty good actually. Now I want to make this feel more like a real environment. I decided to add a new skybox, so I looked for a bit and decided on something with spacey vibes. It's kind of fun, isn't it? Then I decided I wanted to model some big rocks or mountains to place along the corners of the map to make it kind of more of a real environment, not just a plane floating in space. So I modeled some mountains and then I brought them into Godot and placed them around the edges of the snow and added collision shapes so you can go through them. Let's just go with this. Now I think what I want to do is make a character that is not a snowball to really show off how this whole system is working, to show that I can make different shapes in the snow. And to do that, I need to model a character. I made a concept sketch yesterday of a very good character. Here, let me show you. This is my concept art. I was nervous about this. This is going to be tough, I think, but I was determined to try. I brought my reference into Blender and started modeling. I mean, it looks kind of similar. Once I finished modeling the penguin, I spent some time figuring out how to paint it, and then I decided I was done for the day. You know, maybe I'll leave this here for today, and tomorrow I can come back and try to animate it and bring it into Godot. I spent a long time here trying to figure out how to correctly rig the penguin so I could animate it. All right, this is a little weird, but we can probably make this work. Then I set out to try to animate the penguin. So I started out by making the idle animation. This penguin's still maybe a little creepy, but at least it's moving. And then I started trying to do the walk animation, but that was tricky. I had to fix some issues with weight painting so the animations weren't impacting unrelated areas of the mesh. And I eventually came up with something even if it wasn't amazing. I decided it was good enough for now, so I brought the character into Godot and it looked okay, but the texture was really patchy for some reason. Why does it look like Frankenstein? That's fine. We'll fix that later. For some quick testing, I just added the snowball movement script to the penguin and got it into the game. But you can see it is working differently because you can see that the feet are showing a line here. And it was working. It was really cool to see the feet leaving marks and the whole deformable snow system actually working. The problem I'm noticing is that its arms should be leaving a pattern too, but they aren't, I think because of a combination of the resolution of the snow mesh and also the blurring I'm applying to the depth texture to smooth things out. So you can kind of see the arms are impacting the snow, but just barely. And I want to see if I can improve that. Let's just try doubling the resolution here. That's probably not very good because it will be like 4 million vertices. I think my computer will be able to handle this because it's pretty powerful, but probably won't work so well on other computers. I mean, that's kind of fun, isn't it? It's still blurred because of the blurring effect, but you can clearly see the arms are making an impact there. Then I decided I wanted to switch the player back to the snowball and have the penguin follow the snowball around instead so that you can actually see the front of the penguin. So I added a texture to the snowball to make it look more interesting, and then I needed to actually get the snowball rolling correctly so the texture looked right, and that was a bit tricky. I eventually figured out how to get it working by taking the cross product of the direction the snowball was rolling and the up vector to get the rotation axis around which to rotate the snowball mesh. Okay, that seems to be working. Got it rolling. Then I started experimenting with having the snowball actually grow as it moved through the snow to simulate it picking up snow along the way. I ended up with some interesting results. Oh, I made it really big. Before coming to a good amount of snow growth over time. I knew it would be better if the snowball actually only grew when it went over areas that had actual snow height, but really I only want to get bigger when it's going over a new area of the map, you know? And I briefly thought about how to make this happen, but I didn't feel like coding it at the time, so I decided I would come back to it later. Then I wanted to make the penguin actually follow the snowball around as it moved, so I wrote some code for that. Feared some issues following, but backwards. But eventually got it working. I mean, it's kind of fun, right? I want to tweak the penguin's size a little bit, but kind of fun how you can see its arms impacting where the snow is deep, you know? And you can see its feet leaving a path too. It is showcasing how this is working, so I think this is a win. There's still a lot more I think I could add to this, but I think it's about time to wrap this up and move on to the next thing. So I just want to add some final finishing touches today. I have a list of things here and I need to pick which ones I actually want to implement. I wanted to add snow particles to the scene coming in from the sky to make it look like it was snowing. I spent a while here experimenting with different parameters and textures, until I got something I liked.
Yeah, this looks fun, doesn't it?
Then I wanted to add in some sound effects. I added in one for when the snowball moves and some background storm noise. I also added a different sound for when the snowball was in the air and when the penguin was walking. I messed around with some material settings on the snowball and added in rim lighting for a cool effect and some subsurface scattering. I also tweaked some similar settings within the ground snow as well. Then I decided I should actually make it so the snowball only grows when it actually goes over fresh snow. My idea was that I could reference the snow mass texture and then convert the snowball's position in the world to a position within the mass texture, and then use that to determine the height of the snowball's current location, and then use that to decide whether to grow the snowball as it's moving. I was having issues getting this working correctly though, so I decided I would just come back and fix it the next day. Fixing the issue I was stuck on was actually pretty simple.
So my thought here is I actually need to look ahead in the texture in the direction the ball is going instead of where it is currently. So to do that, I should be able to use the velocity in the direction. This is messy, but this might be right.
That worked, and now the snowball would only grow when it was actually going over fresh snow.
Okay, cool. That's, I think, working now.
Then I wanted to add something pushable to the scene to let you play with the snow more. So I added a box mesh to the scene and made it so you could interact with it with the snowball.
Oh, okay, that's easy. Doesn't really make sense that it's sliding like this, but that's fine.
Then I wanted to fix the Frankenstein-looking penguin texture. I eventually figured out this was an issue due to bitmaps being generated when the penguin textures were imported.
Look at that. No more Frankenstein penguin. I think what happened here is that I didn't have enough space in my UV map here, so when Godot tried to create bitmap versions, it kind of creates seams in them, and probably the way to fix that would actually be to create the textures differently in Blender and make sure I have enough space between the UV islands, but that will be for next time.
And it made the pushable block look more like an ice cube material-wise. Then I decided to add some more penguins of varying sizes to the scene. I wrote some code to get the other penguins to walk around randomly within an area.
This little one is pretty silly. Charging through the snow.
And then add some more pushable objects of different sizes and shapes to the scene so you can really see how this whole system's working.
Look at that little ring of snow in the center, that's fun. This is pretty fun because you can see how this whole system is working, how all different shapes impact the snow.
Then I decided I had one final very important thing to add, a penguin with a snow angel animation. So I spent a while making an animation in Blender and brought it into Godot, and I made a large penguin with the animation and put it in the scene, and it looked pretty good.
All right, could the animation be better? Yes, but it's making a snow angel.
Then I decided I was finally done.
Okay, I think I'm done. This took a lot longer than I was planning, but I think it turned out pretty well.
So this is the final project, and I'm really happy with how it turned out. It feels super satisfying moving through the snow and seeing how all the different objects and characters impact it, and I'm really happy I implemented it the way I did. This project did take me a lot longer to get through than I was initially expecting because I encountered a lot of new to me problems and things I just didn't understand that well, but I'm glad I pushed through it because I learned so much, and I'm really happy with the final result. If you'd like to try out the project yourself, I'll have it up on itch.io and linked in the description, but no promises as to performance right now. If I was using this technique in an actual game, I would have to spend a lot longer thinking about how to improve performance and probably decrease the resolution of the snow mesh, but for now it's fine. Also, if you're interested in supporting my channel and also getting access to the code for this project and all of my previous projects, I have a Patreon page that I'll link in the description. Thank you so much to everyone who's already supported me over there. I really appreciate it. Thank you all for being here and for watching, and I'll see you in the next video.